Hi boys and girls, this is lecture 3.2 in unit 3, the second part of a lecture entitled Product and Quotient Rules and Higher Order Derivatives. On this first slide, we reiterate the two all-important rules discussed in the first part of this lecture, the product rule and the quotient rule. The product rule states that when you have a product of two functions, f of x and g of x, the derivative can be taken by multiplying the first function times the derivative of the second, adding the second function times the derivative of the first. The quotient rule states that if you have a quotient of two functions, f of x over g of x, the derivative can be taken by taking the denominator function g of x, multiplying it by the numerator function's derivative f prime of x, then subtract the numerator function f of x times the derivative of the denominator function g prime of x. All of this over the denominator function squared. After learning the derivatives of sine and cosine, weren't you so curious as to the derivatives of the other trigonometric functions? Well, today is your happy day. We learned the derivatives of the other four trigonometric functions. The derivative of tangent is secant squared of x, cotangent, negative cosecant squared of x. The derivative of secant, secant x, tangent x, and the derivative of cosecant, negative cosecant x, cotangent x. Notice there's a similarity in the derivatives of the cofunctions. The derivative is the cofunction, but the negative of it in both cases. So hopefully that will make this easier to memorize. And memorize these you should as soon as possible. Let's take a few derivatives involving trigonometric functions. Here we have y equals x minus 10x. The derivative then will be y prime is equal to the derivative of x, which is 1, minus the derivative of tangent, which is secant squared x. And that's it for this one. For this second example, we do have a product. So the first function f of x will just be x, and g of x will be secant x. We must use the product rule. You can't just take the derivative of x and secant x and stick them together. Since it's a product, you must use the product rule. Y prime then will be the first function times the derivative of the second, and the derivative of secant x is secant x tan x, plus the second function, secant x, times the derivative of the first, which is just a 1. Now, technically, this is your derivative, and it's almost as simplified as it can be, but perhaps just for fun, we will factor out the secant x. Since both terms have it, that leaves x tan x plus 1. Now let's take a derivative a couple of different ways. First, using the quotient rule. In this quotient, the numerator function, 1 minus cosine x, the denominator function, sine x. Let's restate the quotient rule. The denominator function times the derivative of the numerator function minus the numerator function times the derivative of the denominator function, all over the denominator function squared. Another thing to memorize. So our derivative will be the denominator times the derivative of the numerator. Since the derivative of 1 is 0, we just need the derivative of negative cosine x. The derivative of cosine is negative sine. So negative negative sine gives us a positive sine x, minus the numerator function times the derivative of the denominator function, which is cosine x. All of this over sine squared x. Simplifying the numerator, we have sine squared x, and distributing the negative and the cosine at one time, we'll end up with negative cosine x plus cosine squared x, all over sine squared x. Hopefully you notice the two pieces of one of your Pythagorean identities here. Sine squared x plus cosine squared x is 1, so this simplifies to 1 minus cosine x over sine squared x. Now I'm going to separate this into individual fractions in order to use some reciprocal identities. 1 over sine squared x minus cosine over sine squared x, but I'm going to separate this into two fractions. Cosine x over sine x times 1 over sine x. Therefore, a simplified version of this derivative is cosecant squared x minus cotangent x cosecant x. Now let's take the derivative a second way, rewriting the original function. I'm going to separate the original function now into separate fractions in order to utilize reciprocal identities. 1 over sine x minus cosine x over sine x gives me cosecant x minus cotangent x. Let's take the derivative of this function. The derivative of cosecant x is negative cosecant x cotangent x minus the derivative of cotangent x, which is negative cosecant squared x. Simplifying this and rearranging the terms gives me a positive cosecant squared x minus cosecant x cotangent x. The exact same thing I got using the quotient rule. So the moral of the story is, it is often to your advantage to simplify trigonometric functions before taking the derivative. We are also able to take higher order derivatives. Just as you can obtain a velocity function by differentiating a position function, you can obtain acceleration by differentiating velocity, or you can think of it as differentiating the position function twice. Here is standard notation for position, s of t. The velocity function v of t is s prime of t, the first derivative of the position function. The acceleration function a of t is equal to v prime of t, the first derivative of velocity, also equal to s double prime of t, the second derivative of position. Here is some notation for higher order derivatives: y prime, y double prime, y triple prime. After 3, usually they use little numbers in parentheses. We have to be careful. This is not an exponent. This is an indication of the order derivative we're supposed to be taking, a fourth order derivative. Again, notation using function notation: f prime of x, f double prime of x, f triple prime of x, and f fourth derivative x, and here's dy dx notation as well. Now we have an opportunity to practice taking a second derivative. The first derivative of this first example, y prime, will be the exponent times the coefficient, 12 over 2, 6, x to the 1/2 power. Remember to subtract 1 from the exponent using the power rule. The second derivative, 6 times the coefficient 1/2, x to the negative 1/2 power, which simplifies to 3x to the negative 1/2 power, which can be rewritten as 3 over x to the 1/2. And there is your second derivative. Now for the second function, we are going to have to use the product rule. So we'll have y prime is equal to the first function times the derivative of the second, plus the second function, sine of x, times the derivative of x, which is just 1. In the second derivative, we will have to use the product rule for this first term, so it will be the first times the derivative of the second. The derivative of cosine is negative sine x, plus the second, cosine of x, times the derivative of x, which once again is just 1, plus the derivative of sine, which is cosine x. Therefore, to simplify, this becomes negative x sine x plus 2 cosine x. That's it for today's lecture. I leave you with this admonition. Makes you wonder what the third derivative of the position function is. God bless you, boys and girls.